Okay, talk now is Einstein messed up philosophy in physics. Einstein messed up philosophy in science and physics. What Einstein did was he changed his philosophy. For a person laying the foundation of a new theoretical approach to science physics, this is terrible, because it causes a schism between his old philosophy and his new philosophy, leaving some of his followers sticking to the old philosophy, others to the new philosophy, and others to some weird hybrid between the two philosophies. So it split his followers. It may seem, so what, that Einstein changed his philosophies. Who cares? We're only interested in physics, not in philosophy. Something some physicists would say, but what he means when he says things changes when he changes his philosophy. What Einstein meant changes. And I'm going to give an example of this. For example, he formed special relativity from his old philosophy, and he says in there that ether is superfluous. So I go to that now. Here we go. I can enlarge it more. On the electrodynamics of moving bodies by Albert Einstein, 1905, his miracle year. If we enlarge it, and he says in here, highlight it, the introduction of the luminescence ether will prove to be superfluous, inasmuch as the view here to be adopted will not require an absolutely stationary space provided with special properties, nor assign a velocity vector to a point of the empty space in which the electromagnetic processes take place. So he's saying ether is superfluous in this paper, his famous paper of 1905. So we go back. So he says his ether is superfluous, and then by his old philosophy that seems to mean discard the ether. And so when you read many textbooks on special relativity, they will say the ether doesn't exist, and that will be by Einstein's old philosophy and his 1905 paper on special relativity. That will come from that. But then in his new philosophy of general relativity says effectively bring back the ether, and this is at, I'm referring to this site here. We go to that one. Right, so go to the top of it. This is Einstein in 1920 when he gave an address to the University of Leiden, and it's written in his book Ether and the Theory of Relativity. It's a little book on that, and this is the English translation of that lecture, published in 1922. We go down. We reach the conclusion of his lecture. If I highlight it, he says, recapitulating, we may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable, for in such space there not only would be no propagation of light, but also no possibility of existence for standards of space and time, and by that it means measuring rods and clocks, nor therefore any space-time intervals in the physical sense. but this ether may not be thought of as endowed with the quality characteristic of the pondable medium as consisting of parts which may be tracked through time. The ideal emotion may not be applied to it. So what is that supposed to mean? To some people that means Einstein brought back the ether in for his general theory of relativity. Some people interpret that as meaning a new type of ether. So there is an old type of ether, and Einstein discarded the old type of ether and he replaced it by a new type of ether. But then, is that really what he means? It seems to be his 1905 paper was written from his old philosophy, and then he had his new philosophy for general relativity, and he seems to be bringing it back again. And if I go to the old philosophy, seems to be a sort of positivism. I go to that and highlight that. This is from Wikipedia. I do Wikipedia a lot, and it's only for sort of general ideas. It's not really precise enough. It does get edited quite a lot, but you can get the general idea of what some of these ideas are. And it says here, positivism is the philosophy of science that information derived from logical and mathematical treatments and reports of sensory experience is the exclusive source of all authoritative knowledge, and that there is valid knowledge, truth, only in this derived knowledge. So it's a type of philosophy. And when we go to its new philosophy, it seems to be some form of metaphysics. This leaves his followers in a state of confusion of whether to interpret things from his old philosophy and, e.g., discard ether, or adopt his new philosophy and accept ether. Whether that is then confusions over, are you rejecting an old form of ether and accepting a new form of ether, or what are you doing when you do that? That is another source of confusion. But you've got here the confusion between the old philosophy and the new philosophy. And in the old philosophy, you seem to be interpreting things like the ether as not existing, but from the new philosophy, you seem to be accepting the existence of ether. And the same thing applies to many other concepts. So Einstein's talking about his concepts of physics. He seems to be changing things from what Newtonian physics was talking about, but then he's got this sudden change again. He's changing from what was his old philosophy to a new philosophy, and that makes utter confusion. It's not, from his writings, it's not very clear what he's talking about. When he's in his new philosophy, is he still adopting things from his old philosophy, or what? Is he accepting part of the old philosophy, or is he rejecting all of it, or whatever? You don't know. It's just confusion in what's going on. And if you're doing that, are you then fitting together a strange mixture of old philosophy and new philosophy? So here we go. It seems that Einstein's old philosophy was what quantum mechanics was based on. So when he rejected continuing with that philosophy, the quantum physicists such as Bohr, Heisenberg, etc. rejected him. And if we go here now, Einstein-Bohr debates, we go here to this link. Here, Wikipedia again, gives you the rough idea. There's Einstein, there's Niels Bohr, and they had a series of public disputes about quantum mechanics. Their debates are remembered because of their importance to the philosophy of science. So a lot of the issue was about the philosophy of science, and it seems to be that Einstein changed his philosophy from the old philosophy to his new philosophy, and the old philosophy of a type of positivism, is what these people would go and buy, the quantum physicists like Niels Bohr. So they rejected his change in philosophy, and that has caused a great deal of confusion. You've then got quantum mechanics based upon Einstein's old philosophy, and you've got general relativity based on Einstein's new philosophy. And then you've got various mixtures of that, kind of like the people who've worked further on quantum mechanics have then tried to interpret quantum mechanics in different ways. But the initial thing seems to be confusion over what Einstein was thinking about. So, on to the next. So let's now get to this philosophical mess. Who I'll be referring to is a John D. Norton. He's at his website address. Right. John D. Norton. This is John D. Norton, Director, Centre for Philosophy of Science, and Distinguished Professor, Department of History and Philosophy of Science, and that's in Pittsburgh. And he's got his CV there, bio. So that's who he is, and he's given a little talk here. I've got him on a talk, and this talk is not coming through very well on the video link, so I've also got slides of it as well, so I might have to pick it up from the slides. Talk has been keep breaking down. So this is where he picks it up from Einstein. Let's have a, yeah, go for it.
Einstein, who is the topic of my present talk. What is distinctive about Einstein is that he sought to integrate his thinking in science and his thinking in philosophy throughout his life. And the interactions between Einstein's scientific work and his philosophical work are very many indeed. Let me indicate some of the philosophical reading that Einstein did.
So he's pointing out the young Einstein in the era time up to 1905 was influenced a lot by philosophical reading, philosophy of science readings, and so he was influenced by these sort of directions: Mac Durham, Spinoza, Hume. So that's what his philosophical influences were at that time.
Throughout his life. And the interactions between Einstein's scientific work and his philosophical work are very many indeed. Let me indicate some of the philosophical reading that Einstein did. These are just a few of the names of the philosophers that we know he read and thought about and influenced his work very greatly. Then correspondingly, and more so later in his life, we find quite a few fundamental philosophical ideas being drawn out of Einstein's work and being brought over into philosophy. Now there's...
So what do we have here is feedback. Einstein, influenced by his philosophy of science readings, etc., and other philosophies, does his theorising, and his theorising in physics is then coming back as being inputted into philosophy. So it's philosophy from his theorising coming back into the body of philosophy.
Lifetime of study already in trying to tease out just the themes that I've put up on the screen here. So what I thought I'd do for you today is pick out just two examples of where Einstein's science and philosophy interacted in very important ways. I've chosen them with two thoughts in mind. One, the episodes I'm going to tell you are not just abstract theorizing, they're part of Einstein working as a physicist. The philosophy was integrated into his work as a physicist. And then secondly, I'm going to talk about them because I think they're less well understood. I think they were very important to Einstein, but in the larger arena, I don't think people are so aware of just how important these particular ideas were. Now, the two episodes are going to be the following. The first is going to be Einstein's discovery of the special theory of relativity. There came a decisive, critical moment in that discovery where Einstein needed philosophical analysis to complete the story.
So, what are we getting here is Einstein's discovery of special relativity is decidedly advanced by his reading of philosophy. So, that was the influence on Einstein for the discovery of special relativity. And when we get to the next bit, general relativity, he's going to change. Einstein's discovery of general relativity converts him to an advocate of an ancient epistolary. So he's changing his philosophy. His philosophy's for that one, for special relativity, and he's changed his philosophy here for general relativity.
He consciously was aware of that, and he consciously used a particular piece of philosophy to finish up the theory. And I'll give you the details of that in a moment. And then the second thing I'll talk about is Einstein's work on his general theory of relativity. And we're going to see, as I work through that his experience with the theory caused him to change his mind almost completely about the correct methods for doing science. It's a very dramatic transformation in the way that Einstein thought about how science ought to be done. Okay, so let me start at the beginning with Einstein's discovery of the special theory of relativity. The discovery itself was reported in this paper here in the Annales de Physique, in English translation, on the electrodynamics of moving bodies. The paper is presented as a complete and perfect whole, and when you read it, you don't get a sense of the many years of struggle that went behind it. This paper was in fact the result of Einstein spending 7 and more years on his own count, struggling with particular problems in electrodynamics, the theory of electricity and magnetism that he'd learned from the 19th century physicists. I don't want to go into the details of these problems. All I want to tell you, though, is that having worked for this long period on these problems, he reached a point of desperation. And it's important to understand that it was a point of desperation. He did not know where to go next. And I can characterize that point of desperation for you in very simple terms, thanks to the way that Einstein set up his own theory. The point of desperation looked something like this. He had to reconcile two apparently incompatible ideas.
And that is totally messing things up. So basically Einstein is desperate for trying to work out what's going on, and so he reaches something which I've dealt with in my other talks is nonsense. If we go to those other talks, my other talks, going into these other things, I have things like this. Einstein's cuckoo process, the way he sort of seems to deal with things, the way Einstein seems to deal with things is to really mess things up, and it's Bernstein Brown has pointed this out, and I've gone through that issue. He really messes things up when he goes through things, and that's what comes out of his point of desperation. but for the Einstein believers, oh, Einstein's a genius.
So I've put a little geometrical figure up here, which is meant to be the reconciling of apparently irreconcilable ideas. On the one hand, he had the principle of relativity. He had been looking at experiments in the electromagnetic ether of the 19th century. He'd been looking at the structure of electrodynamic theory. He'd been looking at classical mechanics. And he'd become completely convinced from all of these areas that one has a complete equivalence of inertial motion. Loosely speaking, physics is the same for every uniformly moving observer. That was the first part of the two things to be reconciled. And then the second was the light postulate. Maxwell's electrodynamics tells you that light propagates at a certain definite speed, 300,000 kilometers per second, 186,000 miles per second, and it's one definite number. Now, there seemed no way for Einstein to get around that. He played around with Maxwell's electrodynamics.
So Einstein is working from Maxwell's electrodynamics, and he gets from that the idea that the speed of light is constant for all inertial observers, and that's the speed of light in vacuum, free of influence of fields and so forth. So that seems to be where he gets the idea from. But as I point out in another talk, that seems to be just a weird interpretation from Einstein to interpret Maxwell's theory that way. It doesn't really seem to be there by itself, but that is contrary to what some of the Einstein believers want to believe. Next.
It's at some length in the preceding years, and that one result was immovable. He could not change it. The difficulty now came when you put the two results together. All uniformly moving observers are equivalent when it comes to the laws of physics. The speed of light is always going to be the same number, 300,000 kilometers per second. So you'll see the difficulty. If I measure a light beam to be moving at 300,000 kilometers per second, and you chase after it, surely you would see the light beam, or you would judge the light beam to be slowed down. But no, if you take both of these principles seriously, you chasing after the light beam must still report back that no, the light is moving at the same speed. That's the problem that Einstein was facing. How is it possible that...
How is it possible? Well, I've dealt with that in my other talks, and that seems to be what's going on here. Einstein's way of dealing with that is to go into a cuckoo process. He starts to do things which don't seem to make any sense. I've lost it. Where has he gone? There. So get back to it again.
Even chasing after light at very high speed, you do not find the light to slow down at all. This produced the great impasse for Einstein, and here's a later recollection of how the impasse was resolved. He talks here, I'll read this full quote later for you, but let me just point at the early remarks here. He talks about this paradox of chasing a light beam, the one that I've just described for you now, and he says that the type of critical reasoning required for the discovery of the central point, right, that solved the problem was decisively furthered, in my case, especially by the reading of David Hume and Ernst Mach's philosophical writings.
So I'll read the full quote. Today, everyone knows, of course, that all attempts to clarify this paradox of chasing the beam of light as his thought experiment satisfactorily was condemned to failure as long as the axiom of the absolute character of time or of simultaneity was rooted unrecognised in the unconscious. So what he's trying to say, he's going to change the idea of what time is. The existing idea of time is absolute time, and he's deciding the paradox of fitting principal relativity to the idea of the constancy of the speed of light in vacuum, in inertial frame and so forth, is you can't join them together unless you suddenly get rid of the idea of the absolute character of time. So that's where he's coming up with the idea of time to be relative. To clearly recognise its axiom and its arbitrary character already implies the essentials of the solution of the problem, i.e. the problem of fitting the principal relativity to the constancy of light speed. The type of critical reasoning required for the discovery of the central point was decisively furthered in my case, especially by the readings of David Hume's and Ernest Mach's philosophical writings. So his influence on making that step to special relativity and having time variable, time relative, comes from his philosophical thinking. So maybe he misunderstood those philosophies of what he was reading. Maybe he didn't understand them properly and got messed up. But he's claiming his ideas are coming from his philosophical readings. He's got a little note. Einstein did not mean Hume and Mach's analysis of the motions of space and time specifically. So presumably Einstein's not even agreeing what Hume and Mach said about space and time. He's just reading them and coming to probably a weird interpretation of what they're saying.
So it's at this point, when he reaches this impasse and he manages to break through, he later tells us it was reading Mach and Hume that enabled him to make the breakthrough, decisively furthered by those readings. Now, this particular passage in Einstein's writings is widely noted, but I think it's widely misunderstood. It's normally presumed that when Einstein mentions Hume and Mach, he was thinking of the work that they did in philosophy of space and time. Mach in particular is very well known for his critique of Newton's ideas of space and time. However, when you start to read a little more carefully in the way that Einstein reports these episodes, it starts to become clear that Einstein was not at all talking about anything in philosophy of space and time. What Einstein was talking about was a very general piece of philosophy that was actually independent of the philosophy of space and time. And in order to explain that to you, let me move on by telling you first what the breakthrough was for Einstein. The key thing that Einstein needed was to develop a new view of the nature of simultaneity. And to explain that, I'm going to use one of Einstein's celebrated thought experiments that explains the result concerning simultaneity. I've simplified it slightly following a later account that Einstein gives in 1915, but this is pretty much exactly the way things were in his original 1905 paper. Let's imagine that we have two clocks here, an A clock and a B clock, and they're set up to emit a flash of light. Each of them is set up to emit a flash of light. The clocks are put at either end of a very long platform, and an observer stands at the midpoint of the platform and waits for these flashes of light to arrive. So the clocks flash, the light signals, they flash, the light signals leave and approach the observer standing at the midpoint. The observer then finds that the two light signals arrive at the midpoint at exactly the same moment. The observer on the platform then makes the following judgment. It follows, the observer says, that the two flashes happened at exactly the same moment. They were simultaneous events. And correspondingly, if the two clocks read the same number when the flashes happened, then the two clocks are synchronized correctly. And you'll see there that the clocks do indicate the same number. They both say 0 when the flashes happen. So this observer here is going to judge that the two clocks are indeed properly synchronized.
It's the person in the middle. Person in the middle, he's stationary with respect to the clocks, and they're emitting flashes of light, and they're emitting the flashes of light at the same time. And that clock's 0 and that clock's 0, and it's coming together. And so this is the midpoint, so he's going to receive these two flashes of light at the same time. And this person is moving along, so he's not quite seeing what this person is seeing. He's seeing something different. So that's where he's going with that, and I think he's totally messed up there, Einstein. So if I can pick it up a bit further on. This is the foundation of how he's getting it from his philosophy. So it carries on here. Inertial observers find the same speed of light, according to Einstein. And this is a setup for speed of light with a rod and two synchronized clocks. And he's so getting the speed c. And then he's considering what's happening from a spaceship. It's back to the same old patterns again on these things. And so this is what his philosophy was then. This is after 7 years of reflection in vain, that was from 1898 to 1905, the solution came to me suddenly with the thought that our concepts and laws of space and time can only claim validity insofar as they stand in a clear relation to experience, and that experience could very well lead to the alteration of the concepts and laws by a revision of the concept of simultaneity into a more malleable form. I thus arrived at the special theory of relativity. So he's thinking that concepts must be grounded in experience, and he's getting all that sort of weird ideas from his philosophical readings, and that's influenced him as to what the physics he's going to form. This is another thing he says. The concept of simultaneity does not exist for the physicist until he has the possibility of discovering whether or not it is fulfilled in an actual case. And this is a weird little example of a hunchback. Quasimodo from the story The Hunchback of Notre Dame. An illustration which Einstein offered in discussion. Suppose somebody used the word hunchback. If this concept is to have any clear meaning, there must be some way of finding out whether or not a man has a hunched back. If I could conceive of no possibility of reaching such a decision, the word would have no real meaning for me. So he's changing the meaning of words. You've got these concepts like space and time, and he's sort of like applying it to the idea of a hunchback. And so if you conceive no possibility of reaching a decision whether a person is a hunchback, the word would have no real meaning for me. And he's saying that in 1916. So he's applying the same sort of thinking to other concepts as he's just said to that word. But when the word has something like hunchback, you would say, well, some people are definitely hunchback and other people only slightly. So there's a wide range of people with varying degrees of hunchback. And I'm not sure from that quote whether Einstein's taken that into account from what he's saying. But based upon this philosophy, he is messing up the existing meaning of words. So he's applying that to simultaneity. So we may purge a priori the absoluteness of simultaneity from our concepts. And I don't think I need to read this, but it's just changing the meaning of words. So he's coming back to this bit of Einstein crediting Hume Mac for his reading Hume Mac about philosophy. He credits them as helping him form his special relativity. It leads him to his ideas about making time relative. I've already read that out earlier. Hume. Let's see what he has to say about Hume.
Presumption you might have is that the work of Mach being closer to Einstein, being in time, and also being more concerned with space and time, that would surely have been the stronger influence. But no, Einstein was very clear, it's the other way around. He says it was still much more Hume who had an influence on him. And here, this comes from a letter Einstein wrote to Schlick in December of 1914. A little confusion over exactly which of Hume's works were read, but I'll...
So Hume influenced Einstein a lot, and we read it here. Your exposition is also quite right that positivism suggested relativity theory without requiring it. Also, you have correctly seen that this line of thought was of great influence on my efforts, and indeed E. Mac, and still much more Hume, whose trustee on understanding I studied with eagerness and admiration shortly before finding relativity theory. So you're having here positivism as having influenced Einstein, and that is when he's doing his 1905 theory. But he's saying this in 1915, so how much is positivism influencing him in 1915?
I'll leave that for another time. And we can do the same exercise of going through Hume's writings, and you find exactly this idea of the complete dependence of concepts on experience, and the inapplicability of a concept if there's not a corresponding experience. And finally, I want to mention something for philosophers here, because those of you with philosophical backgrounds are now wondering, well, why Hume more than Mach? Why Hume more than Mach? My conjecture is the following. Mach was more rigid than Hume. Mach really wanted to purge any concept out of science that did not have a proper grounding in experience, whereas Hume was willing to tolerate concepts that did not have a proper grounding in experience. If you want the obvious and clear example of that, for Hume, the idea of cause and effect, or causation, as an unseen hand that necessitates, that is not grounded in experience. But he's willing to allow us to use that as a kind of habit of thought. And I think Einstein found that more congenial than the rigidity of Mach. And he has some fairly stern things to say about Mach and some fairly comfortable things to say about Hume. In particular,
So if I read these, a conjecture, Einstein thought that Mach, but not Hume, denied the freedom of creation of concepts exercised by Einstein when he introduced a new definition of distant simultaneity in 1905. Question mark. This is Einstein saying in 1948, I see Mach's weakness in this, that he more or less believed science to consist in a mere ordering of empirical material, that's experimental material. That is to say, he did not recognise the freely constructive element in the formation of concepts. In a way, he thought that theories arose through discoveries, not through inventions. He even went so far that he regarded sensations not only as material which has to be investigated, but as it were as the building blocks of the real world. So Einstein is not so well. Mach is thinking in terms of making discoveries, and that's what's moving science onwards, and Einstein is sort of thinking in terms of changing the meaning of concepts. So next, Hume saw clearly that certain concepts, as for example that of causality, cannot be deduced from the material experience by logical methods. So Einstein's changing everything. He's changing the existing idea of the concepts.
The other place that Hume is mentioned in Einstein's later recollections is with regard to the theory of causality. Okay, so here's a summary of how Einstein used his theory of concepts in the development of special relativity.
So it's the way Einstein's dealing with concepts and physical theory. So concepts must be properly grounded in experience, else they fail to represent the physically real and are fictional. He's getting that from Hume and Mach. Concepts without proper physical grounding need not be abjured, contrary to Mach and Hume. They can be retained in physical theory as long as their arbitrary character is recognised and in a way that does not unwittingly introduce false presumptions. The breakthrough in Einstein's discovery of special relativity came when he applied this view to the traditional concept of the simultaneity of distant events.
The basic claim is that concepts have to be grounded in experience, else they fail to represent the physically real and the fictional. He's getting that from Hume and Mach. But in addition, he then says that concepts without proper grounding, they don't need to be purged out of your theory entirely. You can leave them in as conventional elements. Einstein introduces simultaneity by definition. As he says, it's the title of the first section of his paper. And no harm is done as long as you keep in mind that these are purely conventional elements.
I'm having a problem here, it's buffeting, so that's pretty bad. It broke down on me last time, so maybe I'll stop it for a moment. We can go to the slides.
Of your theorising that should have no prior authority over you. And then finally I make the point, of course, that this enabled Einstein's breakthrough. Okay. Now let me move on to the second part.
So he's come back again.
I want to say a little about Einstein's discovery of the general theory of relativity. Again, it was a process that took very many years, roughly from 1907 to 1915. And in this case, we have a lot of information about the various stages that Einstein passed through, and that's going to prove very helpful to us. For those of you who don't work in the physics, the general theory of relativity is Einstein's greatest discovery without any question. It's the one that towers over everything else that he did. The basic idea is the following beautiful, luminous idea, and that is gravitation is to be understood as a curvature of the geometry of space-time. So it's a pulling together of gravity, the falling of apples, and the geometrical curvature of the structure of space-time. It's a beautiful and wonderful idea, and I won't be explaining it to you at all. So let's move on. What I am interested in, though, is something that is, I think, easier to grasp at the first pass. Einstein thought a lot about the methods that he used. And from looking at his papers and correspondence in the period that he was working on general relativity, you can see that Einstein himself conceived of there being two ways that you can advance to a physical theory. And he described these, and we will describe them, as a physical approach and a formal approach. And it's the tension between those two approaches that I'm going to be tracing through over the next few minutes of speaking here. Let me say a little bit about the physical approach first. The physical approach is the one that we think of in conjunction with the earlier Einstein. The idea is that you advance to new physical theories by finding physical principles that have an evident empirical support. For example, the principle of relativity or the conservation of energy. All of these things are closely grounded in experiment and experience. Then the next thing that you do is you pick out certain limiting cases where you are very secure of how the physics goes. So Einstein knows what's going to happen in space and time if there's no gravity.
I'm pointing out, I'm emphasising what you pointed out, that this is the Einstein 1905 when he's going by the old philosophy. Physical approach to base yourself on physical principles and so forth.
At all. That's a clear case. Or if the gravitational field is very weak, then things must look Newtonian. And then the extreme example of this would be the idea of physical naturalness, and that gets expressed most purely in Einstein's beautiful thought experiments. These are thought experiments in which certain physical ideas are laid out for you in beautiful pictures. You see the thought experiment and everything clicks and you just get the idea. Right? That's one way of proceeding. That's the physical approach. But then there's a formal or a mathematical approach. In the formal or the mathematical approach, you look at other things in the physical theories. So one of the things that became very important for Einstein is...
So I think... Oh, that's perfectly, yeah. I think the formal approach is sort of where he's becoming more mathematical in the formal approach is where he's becoming more mathematical in forming general relativity. He's bringing in a lot more maths. Has it failed completely?
It's
Seem to be back again, just had to find the place. Back here. So the formal approach is where Einstein's becoming more mathematical when he's developing general relativity.
Einstein. The idea is that you advance to new physical theories by finding physical principles that have evident empirical support. For
Einstein
example, the principle of
1905.
relativity or the conservation of energy. All of these things are closely grounded in experiment and experience. Then the next thing that you do is you pick out certain limiting cases where you are very secure of how the physics goes. So Einstein knows what's going to happen in space and time if there's no gravity at all. That's a clear case. Or if the gravitational field is very weak, then things must look Newtonian. And then the extreme example of this would be the idea of physical naturalness, and that gets expressed most purely in Einstein's beautiful thought experiments. These are thought experiments in which certain physical ideas are laid out for you in beautiful pictures. You see the thought experiment and everything clicks and you just get the idea. Right? That's one way of proceeding. That's the physical approach. But then there's a formal or a mathematical approach. In the formal or the mathematical approach, you look at other things in the physical theories. So one of the things that became very important for Einstein is how quantities change when you start changing the coordinate systems that are being used to evaluate them, or when you have group properties that I won't go into. It then becomes an important tool of theory construction to start looking at the mathematical theorems that govern the transformation properties of these particular quantities. And then finally, the correlate of this idea of physical naturalness is formal naturalness, and then the very strong technique, the analog, if you like, of the thought experiment, is to pick out the equations that are somehow mathematically most simple. Right? And writing down the most simple equations is a way of getting to a physical theory. Now you can see these are two very different approaches. This one is very much based in a physical understanding of the world and physical instincts. This one's very much based in a presumption that the mathematics is leading you in the right direction, always lead.
So it's two approaches. The first one physical and this one mathematical. So 1905 seems to be going a physical approach, and then with general relativity his approach is becoming more mathematical. So there is conflict in sort of some of the scientists and the dissident scientists that I talk to, that they seem to want to reject mathematical approach to things, and so they want it grounded more in the physical. So you've got this sort of conflict from Einstein, where first of all he starts physical and then he goes mathematical. So pick it up again.
Is a way of getting to a physical theory. Now you can see these are two very different approaches. This one is very much based in a physical understanding of the world and physical instincts.
Well, we've got the problems again.
This one's very much based in a presumption that the mathematics is leading you in the right direction, always leading you in the right direction. I recognise there's some overlap between these, and you can find that one or the other of these ideas is in some sense an expression in different words of similar ideas, but I'll pass over that. Now, in having laid that out, let me just mention that the idea of looking at these two different approaches is something that I worked on in collaboration with some colleagues of mine at the Max Planck Institute for the History of Science in Berlin, and we produced this 4-volume work, The Genesis of General Relativity. It's not cheap, but
over $1,000.
Very big volumes that will impress your friends. But still, if you want to see vastly more that I'm going to say here in vastly more detail than any reasonable person could ever want, then you'll want to get hold of these books. And I don't think I get royalties. So, all right. So let's now get back to Einstein. The story that we're going to see is a complete transition in the way that Einstein thought the methods of physics should run. Okay? And I want to remind those of you who know a bit about Einstein, those of you who don't, I'll be telling you for the first time. Early in his life, Einstein had a very clear disdain for mathematics.
So early on, Einstein had a disdain for higher mathematics and physics, and that would be when he was in about the 1905 when he was doing special relativity. And so special relativity, like quantum, used only calculus of many variables, and Einstein had a marked reluctance to adopt Minkowski's four-dimensional methods. Minkowski brought in a lot more maths to special relativity. He does not use them until 1912. So Einstein didn't want to use more of the maths which Minkowski was introducing. And then he has a quip, this is Einstein, I can hardly understand Larry's book, which was a textbook on special relativity, presumably because there's too much maths in it. Four-dimensional methods disparaged as superfluous learnedness. So Einstein, having a disdain for higher maths early on in the 1905 time, which could explain why when you look at the maths in his 1905 paper, it's so much nonsense. And so if I go back to my videos, if I can find them again, not that one. So when you go into look at the maths of Einstein, it's very weird, it's full of mistakes, and I've got one here. Next. that one. I go into some of the maths that Einstein uses in the 1905 time, and it's just nonsense. So he's building on nonsense as regards maths in 1905, and that's part of his disdain of maths. Find it back again. So it's very weird. So suddenly he doesn't like maths in 1905, and suddenly he's changed his mind for general relativity, and he wants lots of complicated maths.
There are numerous very short anecdotes about how Einstein was disparaging of mathematicians. I'll just mention one of them. In 1907 and 1908, Hermann Minkowski took Einstein's special theory of relativity and cast it in a mathematically beautiful form of the four-dimensional formalism. Einstein regarded this, as he said to, I can't remember who he wrote that to now. This was in correspondence fairly late on, 1911 or 1912. He regarded that as superfluous learnedness. He thought it was simply unnecessary. All of his early work was done with very simple mathematical methods, just the calculus of many variables, nothing terribly sophisticated. Now, it's important for us to nail down that this attitude was clearly in place quite late in the story. Remember, the discovery of general relativity spanned a period of 1907 to 1915. Well, as late as 1912, something very interesting happened. Max Abraham produced an alternative theory of gravity, and he produced this alternative theory simply by writing down which were the mathematically most natural equations to write down if you wanted a relativistic theory of gravity. If there are any physicists here, you'll instantly recognize that that's about as the simplest four-dimensional generalization that you can possibly get of Newton's theory of gravity. The details of the theory don't matter to us. What matters to us is that Einstein really hated this theory. Right? And he started writing to all of his friends. And I just started collecting words from the various letters that he wrote to his friends, telling them that the theory, this is to Ehrenfest.
So I point out that Einstein in 1912 is condemning this sort of theory because it's formal, and Einstein is later on, in about 1915, going to adopt the formal approach. So he's condemning something which he's later going to adopt. And these are the sort of quotes he's saying. He's sort of like saying totally untenable, incorrect is every respect, totally untenable going there. So he doesn't like a formal approach at that time, and he's later going to change his mind.
Totally untenable. To Wien, totally unacceptable. To Lawrence, incorrect in every respect. And to his friend Sanger, totally unintelligible. It's just this barrage of complaint, right? And what's most interesting is the basis upon which he complains about the theory. He complains about the theory, as I give you in these two quotes, because it's based on the idea of writing down the mathematically simplest equations. So he says this theory, has been created out of thin air, i.e. out of nothing but considerations of mathematical beauty, and is completely untenable. Okay, I want you to just keep that in your mind. Einstein is damning something. He's saying, look, you've put a theory together out of nothing but considerations of mathematical beauty. Don't you know better than that, right? This is the complaint of 1912. Remember that, because you're going to see things change a little. Well, the first moments of change began sometime late in the summer of 1912. Einstein moved to Zurich and began collaborating with Marcel Grossmann. Marcel Grossmann was a mathematician and Einstein's university friend from Zurich as well. And Grossmann started helping Einstein plough his way through a rather difficult and large mathematical literature. And in particular, it was Grossmann who pointed Einstein towards the calculus of Ricci and Levi-Civita, which has the modern mathematical methods that are used in general relativity. And in it, you find the mathematical structures out of which the general theory of relativity is built. In particular, at some point, we're sure of this, Marcel Grossmann would have said to Einstein, this is the thing you need to work with. This is the Riemann curvature tensor. It's this enormous 4-index quantity, second-order derivatives.
So in this time period, Einstein is getting more into complicated maths from introduced to it by this person, Marcel Grossmann. He's taking on a formal approach.
Linear, it's just a nightmare for a physicist to want to even look at. But we know there was a moment when Marcel Grossmann must have done this. We can only imagine Einstein's reaction. Now, it's in the middle of this that Einstein now starts to make concessions. He talks about all the difficulties he's working with, and he's saying, one thing is certain, never before in my life have I toiled anywhere near as much, and I have gained enormous respect for mathematicians, whose more subtle parts I considered until now, in my ignorance, as pure luxury. Compared with this problem, the original theory of relativity is child's play. Right, so we see Einstein's weak...
So that is his changing of philosophy from his earlier philosophy about 1905 when he was on special relativity. He was disdaining mathematics, and now he's taking on a mathematical induced philosophy. Now he's finding the maths complicated. He's taking on a different philosophy.
He's now starting to develop respect. Okay. It all leads up to this paper here. This paper written, it's a two-part paper written with Grossmann in 1913. It's an outline or a sketch of a generalized theory of relativity and a theory of gravitation. It, in fact, has the complete theory of general relativity in there. The entire theory is there, the complete structure. It's all there, except one piece. And the one piece that's missing is the most important part. And these are the so-called Einstein gravitational field equations. If you work in physics, you know what that is, and you know that not having that is bad. If you don't work in the physics, the analog of what just happened is this. It's imagine Newton creating the complete Principia with all the theorems and everything intact, but not having an inverse square law of gravity. It's trouble. You know, whatever else he's going to put in there, it's just not going to work. That was the situation that Einstein was in. Now, it was interesting. It's not that Einstein didn't think about the Einstein equations. It's not that he didn't consider something pretty close to them. In Grossmann's mathematical part of the paper, the standard setup is approached. I mentioned to you the Riemann-Christoffel curvature tensor. This is the basis out of which general relativity is built. And there it is. And then they take the first steps that are needed. They do a first-order contraction. First, they do just the first contraction down to a 2-index symbol. All the steps are being taken as you would expect. And then there's a sudden disaster. Then Einstein just announces, or Einstein and Grossmann just announce, that it doesn't work. You don't get Newtonian theory out in the limit. Right? Now, if you've worked on general relativity, this has to be a jaw-dropping moment, because here's Einstein with the complete structure.
What strikes me from this is it's all sort of bodging, really. He's prejudiced already. He wants Newtonian physics as coming out as a limit, and he's sort of like trying to bodge things to get that.
Structure of general relativity, then telling you that the Einstein equations are the wrong equations. Right? A surprise that this could happen. And then it gets worse. Then Einstein and Grossmann set them aside and cook up field equations for the theory that have very bad formal properties, and then publish the paper. Right? It's not a good thing that's happened. And of course, one of the big puzzles for us in history of relativity is to try and figure out what on earth happened. How could this happen, that Einstein could take such a devastating wrong turn at the very last moment? Well,
devastating wrong turn at the last moment, but as far as most of us are concerned, the distant movement, Einstein was always making wrong turns. It's just a mountain of wrong turns. It's a mountain of mistakes.
Is that we can solve the problem almost completely. Because it turns out that the notebook of calculations that Einstein kept during this period has survived. And it's possible for us to go through this notebook of calculations step by step and understand what happened. I flipped it over because this is one side of it, and it says notes for lectures on relativity. It's mislabeled. They aren't notes for lectures. This was the way it was kept in the archive. Here, I think you can see faintly the words relativity. So Einstein worked from both ends in the book. And I'll tell you in brief what the story will be. No need to keep you in suspense. When you go through the book, what you discover is Einstein using the two methods that I described, this physical approach, the mathematical approach, and his hope, his expectation, was that the two approaches would meet and give him the same result at the end. But unfortunately, when he started working through the material, it didn't go that way. The physical approach led one way, and the mathematical approach led another. Right? And he had to make a choice. Which way do you side? Do you side with the physical thinking, or do you side with the mathematical thinking? He had to choose, and he chose for the physics. And it turned out to be the wrong choice. And he visited some 2 to 3...
It turned out to be the wrong choice, but really, from most of our point of view, he was always going wrong. He already, as far as I'm concerned, he already started wrong. He just carried on.
years of misery upon himself while he tried to figure out what went wrong. And so that's the story that's coming. I'll show you 1 or 2 pages of the notebook, but I don't think there's time for me to linger here because it's getting on. This is an amusing page. This is the inside cover. I don't know if anyone can recognize what this is. I'll give you a hint. This is a puzzle in recreational mathematics, right, to do with rearranging geometrical figures. What you can...
So I don't think that is quite relevant. It's doodling in his book, really. He's doing recreational maths. That bit's not quite too relevant. He's going on, carrying on with the formal approach, making lots of complicated mathematics now for his general relativity. Giving a formal approach to the gravitational field equations. One of the things is he's representing the gravitational field as space-time curvature. I don't see why you need to do that. Keep it as a gravitational field, I would say. That's the way he's doing it. And then there's something about... Then he's finding failure with the formal approach. Einstein finds multiple problems with the gravitational field equations based on the Riemann curvature tensor. And so he's just struggling on. He's so supposed to have solved the problems, but as far as I'm concerned he doesn't, and I think other people at a distance consider he hadn't solved the problems. It's just a mess. And he's talking about feeling tired after all his struggles. In 1914, when he's struggling away with general relativity, trying to get it working, he's struggling. So then in 1915, still struggling away, he realises N-off field equations are wrong and returns to spec generally covariant to seek generally covariant equations. So he's realising some of the things he's done wrong and he's changing it. At the same time he's doing that, Hilbert is working on it as well. Some people think Hilbert really discovered general relativity, but it's another big controversy. So this is the bit where we're picking up when Einstein's new methodological morale, and he's been triumphant with getting his general relativity, triumph of formal methods over physical considerations. So say triumph of the formal method over the physical method. And Einstein saying, I have already taken into consideration the only possible generally covariant equations which now prove to be the right ones. 3 years ago, with my friend Grossman, only with heavy hearts did we detach ourselves from them. Since the physical discussion has apparently shown their incompatibility with Newton's law. And it's general sort of waffle. He suddenly thinks he's been successful. We pick it up now.
The only possible generally covariant equations which now prove to be the right ones 3 years ago. Right? Why didn't he accept them? Only with a heavy heart did we detach ourselves from them, since the physical discussion had apparently shown the incompatibility with Newton's law. It was the physical discussion that had drawn him astray. He could have gotten there 3 years ago if only he had not taken the physics so seriously, if only he had taken the mathematics more seriously. He says here, this time the most obvious was correct. Right, where most obvious is now, of course, the mathematical pathway. And then listen to this. This is now you've got to remember, the Einstein of 1912 complaining about mathematical simplicity as a guide. Right, the Einstein who was disparaging to Max Abraham for his theory. And now this is Einstein writing. Hardly anyone who has understood it can resist.
So Einstein has changed his philosophy. 1 minute opposed to complicated maths, and now suddenly finding he adopts complicated maths, changing his philosophy. He's talk on this one here.
The charm of this theory, it signifies a real triumph of the method of the general differential calculus founded by Gauss, Riemann, Christoffel, Ricci, and Levi-Civita. So now suddenly Einstein is on the other side, and he's touting the idea of mathematical simplicity. Now this was a
Here we go again. There's not that much more to go.
Formative moment for Einstein. It began a complete transition in the way that he did physics. This idea of tracking down the mathematically simplest.
As he said, a transition from the way he's doing physics. This is change in philosophy.
Equations as the right equations flowed from this. There's a very beautiful statement of all of this that comes later on, and this is a lecture that Einstein gave in Oxford, June 10th of 1933, the Herbert Spencer lecture. And I'll just quote from you, it's a rather long lecture, but I'll just quote from you the central part because it really gives you the idea in a nutshell. Einstein starts out by asking the following question: how can we know which is the right way to go? In other words, which is the right theory to pick, when you can get many theories that do justice to experience well enough? Right? You get many theories and they all work near enough. How do you know which is the right one? Is there a way? And he answers, yes, without hesitation, there is, in my opinion, a right way. And then he starts out with this wonderful sentence: our experience hitherto. Now, when Einstein says our experience hitherto, I don't think he's just meaning our communal experience. I think he has in mind, in particular, that experience that he had in 1915. It's real experience. It's the experience of a working physicist. Our experience hitherto justifies us in believing that nature is the realization of the simplest conceivable mathematical ideas. I am convinced that we can discover by means of purely mathematical constructions the concepts and laws connecting them with each other, which furnish the key to the understanding of natural phenomena. Now, those of you who know some philosophy will recognize this as out-and-out Platonism. This is a straightforward Platonism. You consult Plato's heaven.
So, Einstein's philosophy seems to be a form of Platoism after he's worked out general relativity. So he starts off as 1905 as a sort of positivism, and then in 1915 he seems to be going towards Platonism. So it's his change to philosophy.
To find the true laws. Does Einstein realize the heritage he simply brought into? I think he very clearly does. Here's the next paragraph. I'll just read the last sentence. First, he's very clear. Experience has an important role. But he says, the creative principle resides in mathematics. And then comes the clincher. In a certain sense, therefore, I hold it true that pure thought can grasp reality as the ancients dreamed. I think this is an amazing reversal.
Ancient philosophy as the ancients dreamed. You're going now on to an ancient philosophy. The modern philosophy is sort of like positivism, and then you're suddenly changing to an ancient philosophy. So part of the problem you can see that physicists like Bohr and Heisenberg were wanting to go by a modern philosophy, and the modern philosophy would be positivism type of philosophy, which is coming from Hume and so forth. And suddenly Einstein abandons that in 1915. After developing general relativity, he acquires a greater respect for mathematics, and then he adopts an ancient philosophy in it, where he believes things in a certain sense. Therefore I hold it true that pure thought can grasp reality as the ancients dreamed, which is the ancient philosophy, Platonism. So you can see that the prejudice is from what is the establishment, the mainstream. They don't want an ancient philosophy. They want a modern philosophy.
For Einstein, the Einstein who was disparaging of mathematics and now regards this as the royal road to the truths of nature. This, of course, became the foundation of his work on the unified field theory to find the mathematically simplest laws. So let me wind up. I could give you a more elaborate conclusion, but I think Einstein can give you a nice conclusion here. Those of you who work in philosophy might see familiar echoes here. The reciprocal relationship of epistemology and science is of a noteworthy kind. They are dependent upon each other. Epistemology without contact with science becomes an empty scheme. Science without epistemology is, insofar as it is thinkable at all, primitive and muddled. Beautiful, beautiful synthesis of ideas there that really describe the way that he did his science. So, if you want to read more about this, I keep a pretty rich and elaborate website. You can go there and sort of click on things and have a bit of fun. I've got a section on the history of relativity, and I've got some popular writing there. I try and tease out things that aren't easily understood. Further down, if you scroll down here, you come to a nice presentation on the Zurich Notebook. More importantly, I've put together a page specifically for this lecture series, and it has this particular talk in it. You'll get the PowerPoint that I spoke to, and you can download papers that explain more of what I was talking about. So here's one paper you can get on the story of the relationship between Hume and Einstein, and then the story behind this wonderful quote: "Nature is the realization of the simplest conceivable mathematical ideas." And again, you'll find that paper there, and that's my story.
So that's the finish of that. So you can see what happened. Einstein changed his philosophy. So Einstein's, if we go back, Einstein's old philosophy seemed to be some form of positivism, and that positivism would be a modern philosophy. And then he changed his philosophy to be in some form of metaphysics, an ancient philosophy. So that's when the establishment broke away from him. They didn't want to go with an ancient philosophy. And it leaves, if we go back to what he's done, Einstein, it leaves it confusing as to what he's talking about. if we try to make sense of things, in 1905 he's saying ether is superfluous, and that's by his old philosophy, which is the positivism type modern philosophy, and he seems to discard the ether, and sort of like by his new philosophy he's bringing it back again. Seems to be bringing back the ether. So if you're reading Einstein, you're saying, oh, how are you supposed to interpret him? Are you supposed to interpret him as saying there is an ether, or are you supposed to interpret him to say there is no ether? It's just confusing. How do you interpret him? Einstein messed up philosophy in physics. He changed his philosophy, and it's messed up how to understand him. It's just awful, really. Sort of, you could say a person who follows Einstein, he could come follow Einstein and say, right, I'm going by what Einstein's philosophy was in the 1905 time, and I'm rejecting what's happening in the 1915 philosophy, and then he's going to say something different to a person who's following Einstein from Einstein's philosophy from 1915 onwards. So you've got this total mess in how you're supposed to understand what Einstein is talking about. Total mess. And if we go back to my video links, my other talks, there we go. So Einstein makes a mess in the maths. That's 1905. Making a mess. He's making a mess again when he goes to higher maths, as in general relativity, as pointed out by Roger Wyden. And we got things like this. Einstein's giving these talks, and he doesn't know what he's talking about, as Dr. Edward Teller points out. Einstein didn't know what he was talking about. So he's messing up everything. Everything is messed. He's messing up Einstein's messing up the maths. Einstein's messing up the understanding of what he's talking about. Einstein's building upon a lie. The lie on which Einstein's relativity is built. Einstein's building on a lie. He's just got everything messed up. Science is supposed to be a process where you correct mistakes. But with Einstein, you just seem to have a ginormous amount of mistakes. It's just incredible the amount of mistakes that Einstein has brought in. It's just unbelievable. There is sort of a limit. You can do a few mistakes, but when you've got a mountain of mistakes, it's unbelievable. It's unimaginable. How can somebody make so many mistakes? I mean, sort of, when you look at that, Einstein changes his philosophy, and people say, "Oh, Einstein changed his philosophy." Einstein changed his philosophy, and they think, "Oh, that's good of Einstein. He changes his mind. He adapts to new facts. When there's a new fact presented to him, he will change his mind and go by that new fact." But really, it's just complete and utter mess. He's changed his philosophy, and it's complete and utter mess, because his theorising was initially based on a different philosophy until what he adopted later. So he really needs to, well, it's too late now. He really needed to explain what special relativity was supposed to mean from the new philosophy he took on from general relativity, and he never did seem to do that, as far as I know. He needed to go back and explain everything again, but he never did it. So he's got the special relativity dealt with by his old philosophy, and then he's got his general relativity dealt with by his new philosophy. And how are they supposed to be connected now? It's sort of what's his thinking process? What's the connection? It's just a schism. It's a split. It's schizophrenic. It's nonsense. It's just nonsense in philosophy. how are you supposed to understand the philosophy behind Einstein's physics now that he's changed his philosophy? You can look at it and say, well, I'm going to have a little mix of his different types of philosophy. Or you can look at it and say, well, I'm going to reject one of his philosophies and take on the other. He's just created complete and utter confusion as to the different ways people can go. So that's it. That's the end, really. That's my conclusion for this talk. Thank you.